Hello everyone, myself Nisha, currently pursuing in first year in Sri Venkateswara College of Engineering. Today I am here to tell you about the applications of unit step function in Triple stream. Introduction to applications of unit step function. The unit step function, also known as the Heaviside function, is a fundamental concept in electrical engineering. It is commonly used to model and analyze dynamic systems in various engineering applications. In this presentation, we'll explore the applications of the unit step function. Signal processing. The unit step function is often used in signal processing to present abrupt changes or transitions in signals. It helps in analyzing the response of systems to sudden changes in input signals. By conveying signals with the unit step function, engineers can study the system's behavior under different conditions. Control systems. In control systems, the unit step function is used to analyze the system's response to step inputs. It helps in determining the stability transist response and steady state behavior of control systems. Engineers use the unit step function to design controllers that regulate the system's output based on the input changes. Circuit analysis. The unit step function is applied in circuit analysis to study the response of circuits to sudden changes in input voltages or currents. It is used to calculate the step response of circuits and analyze their performance under different operating conditions. Engineering use the unit step function to design circuits with desired transist and steady state characteristics. Digital signal processing. In digital signal processing, the unit step function is used to model and analyze discrete time systems. It helps in studying the response of digital filters, controllers, and other systems to discrete step inputs. Engineering utilize the unit step function to design and utilize digital signal processing, algorithms, or various applications. System identification. The unit step function is employed in system identification to estimate the parameters of dynamic systems. It helps in modeling the system's behavior based on input-output data and determining the system's transfer function. Engineers use the unit step function to identify and characterize the dynamics of systems in real-world applications. Feedback control. In feedback control systems, the unit step function is used to analyze the closed loop response of systems. It helps in evaluating the stability, performance, and robustness of feedback control systems. Engineers apply the unit step function to design controllers that ensure the desired system behavior in the presence of disturbances. Communication systems. The unit step function plays an crucial role in communication systems to analyze signal propagation and distortion. It helps in studying the response of communication channels to step inputs and designing equalization techniques. Engineers use the unit step function to optimize the performance of communication systems in terms of signal quality and reliability. Power systems. In power systems analysis, the unit step function is utilized to study the transient and steady state behavior of electrical networks. It helps in analyzing the response of power systems to sudden changes in load and fault conditions. Engineers rely on the unit step function to design protective relays, control schemes, and stability enhancement techniques for power system. Filter design. The unit step function is commonly used in filter design to analyze the frequency response of filters. It helps in determining the filter pass band, stop band, and transition characteristics. Engineers apply the unit step function to design analog and digital filters with specific performance specifications for various applications. Time domain analysis. The unit step function is essential for time domain analysis of systems to study their transient and steady state responses. It helps in determining key performance metrics such as size time, rise time, setting time, and overshot. Engineers use the unit step function to evaluate and optimize the time domain behavior of systems in different engineering disciplines. Frequency domain analysis. In frequency domain analysis, the unit step function is used to analyze the system's response in the frequency spectrum. It helps in determining the system's frequency characteristics such as gain, phase shift, and bandwidth. Engineers leverage the unit step function to design systems with desired frequency domain specifications for optimal performance. Feedback amplifiers. The unit step function is applied in feedback amplifiers to analyze their stability and frequency response. It helps in designing amplifiers with improved gain, stability, bandwidth, and distortion characteristics. Engineers use the unit step function to optimize the performance of feedback amplifiers in audio, instrumentation, and RF application. Transist analysis. The unit step function is used in transist analysis to study the system's response to sudden changes in inputs. It helps in evaluating the system's behavior during startup, startdown, and disturbances. Engineers utilize the unit step function to design systems that exhibit desired transist responses for reliable operation. Impulse response. The unit step function is related to the impulse response of systems through differentiation. It helps in deriving the system's impulse response from its step response and vice versa. Engineers use the unit step function to analyze the relationship between step and impulse responses for system characterization. Simulation and modeling. The unit step function is employed in simulation and modeling of systems to predict their behavior under different scenarios. It helps in validating systems models, evaluating performance metrics, and optimizing designs. Engineers utilize the unit step function to stimulate and analyze complex systems in a virtual environment before implementation. Real-time control. The real-time control applications, the unit step function is used to implement control algorithms for dynamic systems. It helps in regulating the system's behavior in real time based on input changes and feedback signals. Conclusion. The unit step function is a virtualized tool in electrical engineering for analyzing, designing, and optimizing systems in various applications. Its applications in signal processing, control system, circuit analysis, and other fields make it indispensable for engineers. By understanding and utilizing the unit step function effectively, engineers can develop innovative solutions for complex engineering challenges. Thank you.